Hi guys, this is the video for Chapter 9, Lesson 6. This is the last lesson of Chapter 9 that we'll be doing. And so after this, we'll do a review and then it'll be test time. So I would recommend you going over your old quiz from Chapter 9, going over that, those questions there. And I might make another video where I just go over some basic concepts over Chapter 9 as well. But today what we're looking at is powering monomials. So far, I guess this can kind of be our review, right? So far, we've talked about exponents and how we started out with the basics, where basically we figured out, okay, if you have a number that's being powered, then really that just means 9 times 9, right? Because this power tells you it's being multiplied 2 times. And we also talked about how we could factor out a number like 12, factor out that to be all primes being multiplied. So we used a factor tree where we could multiply this out 4 times 3, and then this became 2 times 2. And so we would write this as 2 times 2 times 3, or you could write it as 2 to the second power times 3. And then we also talked about multiplying and dividing monomials. So if we have monomials that have the same base, like 5 to the third power times 5 to the second power, this becomes 5 to the fifth power. And we talked about how really you could break this down into 5 times 5 times 5, 3 times. This could be broken down to 5 times 5. And then you have 1, 2, 3, 4, 5. So you just add these exponents and you have the answer there. And then with division, if we have like 9 to the sixth power over 9 to the second power, we could subtract them and you would have 9 to the fourth power. So remembering these rules of adding the exponents or subtracting the exponents and how you work that out is big. And so then when we, right before our spring break, we also talked about powers, right? Scientific notation. So if I wanted to write a really big number, I could write it as scientific notation. So I could write 2.097 times 10 to the fifth power. And that really is saying I'm going to move my decimal five times over to the right. And so this becomes, and I have two placeholders, 0, 0. So 0, 0, 209,700. Or if you have a really small number, like 7.8 times 10 to the negative 6. So this negative 6 means you're moving it to the left. You're moving your decimal to the left 6 times. 1, 2, 3, 4, 5, 6. And then this would be where your decimal is. So then all in place of this, you would have placeholders. So there's 5 zeros in front of your number. And then 7, 8. So it's 0.000078. So those are basically the things that we've done up to this point. Now today we're going to talk about powering a monomial. So if I have, h to the fourth power, and all this is to another power, so that to the third power, how would we work this out? So what we're going to take a look at is first breaking this h to the fourth power and say, okay, well, I'm going to look at h to the fourth power as one term, one little monomial, and I'm going to power it 3 times because it says it's to the third power. So h to the fourth times h to the fourth times h to the fourth. Now, if I break this down even more, h to the fourth, I have 4 h's for each one. 1, 2, 3, 4. And remember, when we multiply exponents with the same base, we can just add them, right? So basically, that's what I'm doing here. So I have 4 plus 4 plus 4, which is 12. So this all ends up being h to the 12th power. So taking a look at the relationship between 4 and 3 and 12 here, what do you notice? And if we did another one, you might see that actually what you see is this is h to the fourth power times 3. That equals 12. So what we realize is really when you have a monomial that's being powered, a power to a power basically, you can multiply them. And I like looking at this parentheses as kind of like a setup. If I connect from 4 to 3, if I connect the two, what I see is I'm making a little tiny multiplication sign. So the relationship between 4 and 3 here with that parentheses is multiplying. So let's just try another one. I'll show you what I mean. Let's do like d to the second power, all that to the third power. So if I look at this, I'm going to connect 3 and 2. So really what I see is 2 times 3. So when I work this out, 2 times 3 is 6. So it's d to the sixth power. Okay, so let's do a little bit of practice on your study guide. And so the rule is really just multiplying it. Okay, so if you want to use my little trick, you can. That only works when I have parentheses, but the parentheses, I see that this is grouped together and that's being powered. So 4 times 3, that's 7 to the 12th power. 7 times 3, that's 12 to the 21st power. This is 8 to the 35th power. This is 22 to the 10th power. You get the idea? So when I have a negative exponent, I'm just going to keep that negative. And so, for example, down here, 4 to the third times, oh, actually not negative. So we're going to multiply it still as it's a negative and just keep it as a negative exponent. So this would become 4 times negative to the negative 15th power. And if you wanted to make this a positive, you could say it's 1 over 4 to the 15th, right? So that's something I forgot to review with you at the beginning. But when our negative exponents, really, we turn it into 1 over that same number to that power. Okay, so with a negative 6 to the second power, we've got negative 6 to the 12th power. And you can leave it like this, or you notice that my power is an even amount. And so I could technically also write it as 6 to the 12th power. So this one would be 5 to the negative 18th power. And if you wanted to write it as a positive, you could do it as 1 over 5 to the 18th. Okay, this one's going to stay negative, I think, because negative 10 to the 10th power and then that to the negative third will make this negative 30. And so if we wanted to do this, this would be 1 over negative 10 to the 30th power. Okay, so with our variables, this would be t to the negative 8th, and I'm fine with you just leaving it like this. We'd have negative s to the 36th power. We'd have e to the negative 18th power, and we'd have d to the 42nd power. So all you're doing is multiplying, right? That's basically all you're doing. And I think you can do 5 through 8 with no problem. Now let's talk about if we have a monomial where there is a number and a variable. Okay, so if I have a monomial where there's a number and a variable, let's take a look at what we should do. So if I have like 3d to the second and then all this to the third, here's the thing. A lot of times when we have something being multiplied outside a parentheses, we can see that we have to distribute that into every term. So really, this third power distributes into the 3 and it distributes into the d, okay? So that means I have 3 to the third power times d to the second power and that to the third power, okay? So that means I have to work this out. 3 to the third power is 27, and then d to the second to the third is to the sixth power. So it would be 27d to the 6th power. All right, so whenever you find the power of a product, find the power of each factor and multiply. You have to find the product of each part of your product here. So let's take a look at the questions that we have down here. So as you can see here, example B, we're going to distribute this second power into every single part, every product, every term in your parentheses. And so this becomes 3 to the second, A to the 4 to the second, and then B to the 6 to the second, okay? So basically, we have, okay, let's work this out. So we have 6 to the third times x to the 5th to the third, all right? And so if you want to use your calculator to kind of find out what these, 6 to the third would be my guest. So this would be 625 times x, 5 times 3 is 15, times x to the 15th. Oh, I'm not correct on that one. This is not 700 or 625. It is 216. I didn't plug it in. 216 x to the 15th power. And that's the answer. Okay, so distributing, you have 5 to the 4th power, which is 600. Here's 625, and then times b. -3 times 4 is -12. So it's 625 times b to the -12th power. And I'm just going to have us stop here and not worry about changing it into a positive exponent. If the directions say write your powers as a positive exponent, then you would have to make sure you change this into a fraction. But if it doesn't say that, you can just leave it as a negative. Okay, so 12 times 12, 12 to the 2nd power is 144. And then h to the 2nd power is 14, or h times 7. H to the 7th power times to the 2nd power is 14. It's a mouthful, isn't it? And so if it helps you to draw the arrows, please do. Now this is -8 to the 3rd power. So -8 to the 3rd power is going to stay negative, and that's 512. And this would be j to the 6th power. Okay, I'm going to pick out a few, maybe 5, 7, 10, 12. Okay, we'll do these 4. So 11 to the 2nd power is 121 times z to the -18th power. 4 times 4 times 4 times 4, 4 times itself 4 times, 256 times g, and then that's to the -8th power. Okay, we've got 3 parts here now, so we're going to distribute into every single part. Now, -9 to the 3rd power is still going to be negative, so 9 times 9 times 9, ooh, big number, 729. And then we have m to the 9th to the 3rd, so 9 times 3 is 27. And then n to the 4th to the 3rd, so that's 12. So I have -729 times m to the 27th power times n to the 12th power. So if you want to kind of underline all your terms so you can see like these are all separate terms, they're just products, they're just being multiplied. 5 times 5 times 5 is 125. And then I have d to the 7th to the 3rd, so that's 20 to the 21st power, e to the 30th power. Okay. I'll do like 2 more, okay? So let's do 13 and 15, just to space it out a little bit. Okay, look here. I've got -4 to the 4th power. Well, this is a negative number to a even power, which is going to make my number positive. So 4 to the 4th power is 256. -4 to the 4th power is also 256, so it's going to be positive. And then I can multiply my exponents, s to the 24th power t to the 32 power. Okay, this one, 8 to the third power is 512, a to the sixth, and then b to the ninth. And that's it. Okay, so that's mainly what you're doing there. So just big thing is getting the rules straight, right?